Hi, welcome back to Moose in Chemistry. This is Lewis Structure lesson number 5. Let's look at the compound CF2S. As we do that, it's important to remember that Lewis structure represents the number of valence electrons around each atom in a compound structure. It's also important to remember that 2 dots equals a dash. Alright, so now we have the compound CF2S. So we're going to cut through the 1 there. That's going to give me 4. So we have 4 valence electrons. Now we're going to look at fluorine, which is in group 17. Take the 1 away, it gives me 7 valence electrons. It's kind of neat knowing the groups affect the number of valence electrons for the most part. Works out really, really well. Okay, and of course, sulfur is in group 16, so it has 6 valence electrons. Okay. Now, so what we're going to do is we're going to set this up. We're going to figure out the number of valence electrons that we totally have. So carbon comes with 1. So we have 1 carbon at 4 electrons. We have 2 fluorines at 7 electrons. We have 1 sulfur at 6 electrons. All right, so let's do the math. So this gives me 4 electrons. This gives me 14 electrons. And this gives me 6 electrons. Looks like it's going to give me a total of 24 electrons. Okay, so whatever we draw has to have 24 electrons in it. But now we've got to determine which one's the core. Sulfur has 2 docking ports, these 2 single electrons. Fluorine has 1 single electron, so has 1 docking port, but look at carbon. It's got 4 docking ports. So carbon is obviously going to be our choice, right? So we're going to put carbon in right here in the middle here. All right, now we have 2 fluorines, so we're going to set the fluorines off. Set right here, and we're all set 1 right here, and we're going to put the sulfur on top. All right, now the first thing we want to do is we want to connect the 3 wraparound atoms to the core. The next thing we're going to want to do is we want to give each an octet. So look, 2, 4, 6, and there's 8. 2, 6, and then there's your 8. Sulfur, 2. Oh, wait a minute, look. Carbon doesn't have an octet. It has to have an octet. So we're going to have to put another line right there to give carbon the octet there. So that gives 2, 4 for sulfur, 6, and 8. Well, let's look at our formal charges to see if this is the best possible structure. Okay? Another note is we have 1 single bond here, which we call sigma. And then we also have a pi bond. The double bond is 1 sigma and 1 pi bond. All right, that's important to remember for later on. All right, now, formal charge right here is valence electrons minus non-bonding electrons minus bonding electron pairs. So we'll do the formal charge first for carbon. Let's see how this works. Carbon came in with 4 valence electrons. Non-bonding electrons doesn't have any left. And bonding pairs, we have 4 of those. So this gives me a total of 0. That looks good. The formal charge for one of the fluorines, because both fluorines look the same, we don't need to do them twice. Fluorine comes in with 7 valence electrons. It has 6 dots around it. So that gives me 6 non-bonding electrons and 1 bonding electron pair. That gives me 0. So that's looking really, really good. So all we have to do is have the sulfur work out for us, and we know we have the best possible shape, right? So let's do the formal charge for sulfur. Okay, sulfur comes in with 6 valence electrons. Non-bonding electrons, it's got 4 of those, because it's got 4 dots, and it has a single bond and a single bond. So there's 2 bonds right there. So that gives me 2 non-bonding pairs, or 2 bonding pairs actually. So 6 minus 4 minus 2 is 0. So this is definitely the best possible shape. All right, there's something else I want you to look at here. We're going to talk about hybridization. Remember that the S has 1 subshell, the P has 3 subshells, the D has 5 subshells, and the F has 7 subshells. So let's do the hybridized orbitals for each of these elements. So carbon, right? Carbon has 1, 2, 3 hybridized objects. So that double bond right here, the double bond, the pi bond that we talked about earlier, you can't count those for hybridized orbitals. Remember, only dots or dashes count. It's only a single dash. It has to be a sigma bond, right? So this gives me 1, 2, 3. So that gives me 1 for S, 2 for P. Here's your 3. Okay, let's do the hybridized orbital for fluorine. Remember, unshared pair electrons and dashes, they're the only things that count. So we got 1, 2, 3, 4. So for fluorine, it would be S, P, 3. Okay, and for sulfur, okay, remember pi bonds right here do not count. Only sigma bonds count. So that gives us 1, 2, 3. That would give me 1 for S, 2 for P. That would give me sp2. Well, guys, that's it. You be snarly, and we'll see you back here at Moosing Chemistry.